It's a continuation of the previous lecture. We will do some more problems on Fourier integral, sine integral and cosine integral. Next problem, find the Fourier cosine and Fourier sine integral of f(x) equal to e raised to minus kx, where x greater than 0 and k greater than 0. So here question is to find the Fourier cosine and Fourier sine integral separately. So Fourier cosine integral is given by f(x) equal to 0 to infinity a omega cos omega x d omega, where a omega is 2 by pi integral 0 to infinity f of v cos omega v dv. And here the function is e raised to minus kx, so f of v it become e raised to minus kv, and given that x value is greater than 0, so the limits will be same, that is from 0 to infinity e raised to minus kv cos omega v dv. And by the integration in reduction form, we can write the integral value as e raised to minus kv by minus k the whole square plus omega square minus k cos omega v plus omega sin omega v within a 0 to infinity. This reduction formula can be formula is written earlier in the above problem. So applying the upper limit infinity, it becomes 0, e raised to minus infinity 0. Applying the lower limit 0, it becomes e raised 0 by k square plus omega square minus k cos 0 plus omega sin 0, and sin 0 is 0 and cos 0 is 1, so it becomes this minus plus, it is k by k square plus omega square. So substituting the value in the given Fourier cosine integral for the value a omega, it becomes f(x) equal to 0 to infinity 2k by pi omega square plus k square cos omega x d omega. Similarly, we can find the Fourier sine integral. Fourier sine integral formula is f(x) equal to 0 to infinity b omega sin omega x d omega, where b omega is 2 by pi 0 to infinity f of v sin omega v dv. The function is e raised to minus kx. F of v become e raised to minus kv, and limit will be 0 to infinity. And by the reduction formula of exponential and sine term, we write as e raised to minus kv by minus k square plus omega square minus k sin omega v minus omega cos omega v with limit 0 to infinity. Applying the upper limit infinity, e raised to minus infinity is 0, and lower limit 0, it is e raised 0 by k square plus omega square minus k sin 0 minus omega cos 0. Sin 0 is 0 and cos 0 is 1, and this is minus plus, so it becomes omega by k square plus omega square, and there is a 2 by pi outside, so b omega value is 2 omega by pi into omega square plus k square. So Fourier sine integral is f(x) equal to, applying substituting the value of b omega here, it becomes 2 omega by pi into omega square plus k square sin omega x d omega. So this is a direct question, that is from by applying the Fourier sine integral and cosine integral formula, we can find the corresponding representation. Now we have a common question, that is show that the integral represent the indicate function. Question will be like this, that is show that integral 0 to infinity sin pi omega sin omega x by 1 minus omega square d omega is equal to pi by 2 sin x 0, pi by 2 sin x if 0 less than equal to x less than equal to pi, and 0 if x greater than y. That is where we have to choose which integral function is needed to solve this problem. That is, we have three integrals: Fourier integral, Fourier cosine integral, and Fourier sine integral. As I have said earlier, if this type of question arises, we have to check along with x which trigonometric function arises. That is, here along with x sine arise, so we have to apply Fourier sine integral. So for solving this problem, we have to apply Fourier sine integral, and for substituting we need a function, so we take the right side as a function. So we take, what is the right side in the question, we take it as a function. So let f(x) equal to pi by 2 sin x 0 less than equal to x less than pi, and 0 x greater than y. That is, if this type of question arise, we have to take the value, the right interval as the given function, and here x term coming together with the sine term, so we have to apply Fourier sine integral formula. So using Fourier sine integral, we have the formula f of x equal to integral 0 to infinity b omega sin omega x d omega, and b omega is 2 by pi integral 0 to infinity f of v sin omega v dv. But here the function has two values. First value lies between 0 to pi, the value is pi by 2 sin x, and second value greater than pi, value is 0. That is, here the interval is 0 to pi, here the interval is pi to infinity, but the value exists only in the interval 0 to pi. We have to take only the value pi by 2 sin v, that is f of v become pi by 2 sin v, and the limit changes to 0 to pi. And we cannot integrate like this. First we have to convert this to the symbol form. So it is, we know that 2 sin a sin b is cos a minus b minus cos a plus b. Here a is v and b is omega v. So this become integral 0 to pi half of, there is no two terms, so we write dividing by 2, that is half of cos v minus omega v minus cos v plus omega v dv. Now we can integrate, because it can be separated as two terms. So taking 1 by 2 common outside, integral of cos v minus omega v with respect to v is sin v minus omega v divided by derivative of v minus omega v. That is, derivative of v minus omega v with respect to v is 1 minus omega. Similarly, second time it becomes sin v plus omega v divided by 1 plus omega. Now we can apply the upper limit pi and lower limit 0. When we apply the upper limit pi, sin pi minus omega pi by 1 minus omega minus sin pi plus omega pi divided by 1 plus omega. And applying the lower limit, since sin 0, lower limit completely 0. Now we can expand the function. We know that sin a minus b is sin a cos b minus cos a sin b, and sin a plus b is sin a cos b plus cos a sin b. And we know that sin pi is 0 and cos pi is minus 1. And substituting and simplifying and cross multiplying, we get the answer as sin omega pi by 1 minus omega square. So this is b omega. So to get the function, substitute the value in the given f of x. Fx become integral 0 to infinity b omega sin omega x d omega. But we have taken f of x as this value, and we have obtained this b of omega as this value. So this is equal, and this is the given question. Show that sin pi omega sin omega x by 1 minus omega square d omega is equal to pi by 2 sin x and 0. So by using the sign integral, we can show that this integral is equal to this function. Now move to second question. Next question, same type of question, that is show that 0 to infinity sin omega cos omega by omega square sin omega x d omega equal to pi by 2 x 0 to 1, pi by 4 0, pi by 4 has the value x equal to 1 and 0 x greater than 1. Here also we can see that along with x term there exists sine terms. We have to apply Fourier sine integral, and for that we have to take the right side as the given function f of x. Write the Fourier sine integral formula, and we have to obtain b omega. B omega is 2 by pi integral 0 to infinity f of v sin omega v dv, and we can see that only the function value exists in between 0 to 1, and the value is pi by 2x. And since this is a point, we cannot express as an integral, so we take only this interval, that is limit changes 0 to 1 and the function value is pi by 2 v sin omega v. Now integrating v sin omega v dv, this 2 and pi will be cancelled, so v sin omega dv by applying integration by parts, that is first term into integral of second minus derivative of this into again integral of this, that is v into integral of sin omega v is minus cos omega by omega minus this derivative of 1 is derivative of v is 1, and integral of this one is integral of cos omega v sin omega, and by omega there is an omega term, so it becomes minus sin omega by omega square. Now we can apply the upper limit 1 and lower limit 0 to the v. So it is applying upper limit 1, it becomes minus 1 cos omega by omega minus plus sin omega by omega square. When we apply the lower limit 0, this one 0 and sin 0, 0. So we get the b omega as sin omega minus cos omega divided by omega square. Now we can substitute the value in the given function. So we get f of x equal to integral 0 to infinity b omega value is this one sin omega x dx. So this interval is equal to the given function. Similarly, we can do the following problems. That is, this problem, it is cos omega x sin omega x by 1 plus omega square d omega. That is, we can say that here x combined together with sine and cosine. That is, we cannot especially apply the Fourier cosine integral or sine integral. We have to apply Fourier integral. That is, we have to find a omega and b omega. That is, here we take this one as a function, and we write the value function as f of x equal to Fourier integral representation, and we have to obtain this a omega, and here the limit only value exists for 0 to infinity integral value pi raised to minus v, and applying the above formula we can easily found a omega and b omega, and we can apply substitute the value in the given function. Now next question, show that e raised to minus x cos x equal 2 by pi 0 to infinity omega square plus 2 cos omega x by omega square plus 4 d omega. So we take this one as the given function, and we can say that here x come together with the term cos term. So we have to apply Fourier cosine integral. So write the Fourier cosine integral formula and find a omega, and here, since here no x value is defined, we take the x value as positive, that is x greater than 0. So the limit changes to 0 to infinity, and the function is e raised to minus b cos omega b dv. Here we have to apply to cos a cos b form. To cos a cos b is cos a plus b plus cos a minus b, that is 1 by 2. Substituting the value, integrating and simplifying, we got the answer cross multiplying, and we got the answer as 1 by pi 4 plus 2 omega square by 4 plus omega raised to 4. So substituting the value in the Fourier cosine integral f of x equal this one. So we get the desired answer. So there are some extra problems given here. That is, first one, sine pi omega sine x omega by 1 minus omega square. We can see that the x comes with sine, so we have to apply Fourier sine integral. Here x comes with cosine, so apply Fourier cosine integral. Here x comes with sine term, so apply sine integral. So these are the first two topics of module, that is Fourier integral. That is, we have learned Fourier integral, Fourier sine integral and Fourier cosine integral. So you have to learn the Fourier integral formula, Fourier sine integral formula and Fourier cosine integral formula. And if if it is specified to apply this formula, you have to apply that formula. If not specified in the given question, you have to check which trigonometric function is came together with the term x. We have to that integral formula is applied. That is, if it is came with cosine, then apply cosine formula. Then if it is came with sine, apply sine formula. Do these extra problems, and if there is any doubt, then WhatsApp me. Please try to do itself the problems. And this topic is very simple compared to the next topic, since the formulas are simple and we can easily calculate. So thank you.